we are also doing with a typical example actually, because I think it would be always better to solve and formulate based on with case study. So here we are taking a 2D heat conduction in a metal block. So you have a metal plate with 1 meter or 1 meter. So placed in such a way that all four edges are kept at a different temperatures, means practically a temperature boundary condition. Fine. Then if you want to calculate this one, this equation can be derived from your three-dimensional heat transfer in a metal block, or a, let's say, metal bar, or let's say rod. So in that case, you will write here, practically if you will write del upon del x k del t upon del x plus del upon del by k del t upon del by plus del upon del z bracket k del t upon del z plus E dot generation equal to rho Cp del t upon del t, right? That would be your three-dimensional heat conduction with generation term, right?
Yes,
Yes,
sir.
sir.
So
Yes,
that,
sir.
hello? So for that case, we want to convert it for two-dimensional, because we have a metal block. So we are considering for time being a two-dimensional one. It can be solved for three-dimensional, but for time being we are solving it only in two-dimensional case without any generation within the materials, and in actually steady state conditions. So rest of the term would varies from here. So this is what is your equation which need to be solved. So this is it, a partial differential equation, and this format of the equation is popularly known by Laplace equation actually. Okay, fine.
Yes, sir.
Yes, sir.
Now this one we want to solve. Now there are the several techniques just to solve a partial differential equation. Some people want to say, let's say you have this variable in y and somehow you want to change it to, let's say, one variable. Sometimes it's possible, sometimes it may not. Because here both are variable, that your t and your y actually. So but for time being, this t would be same at particular x y. So whatever you have, so t is not a variable. Only x y is the variable here, right? So at a particular x y position is fixed. It won't change whether you calculate t y x or t x y. Both are same actually. So we want to solve this first by finite difference, because so far we are talking about finite difference one. Because finite difference is easy actually, so easy to formulate compared to other techniques. So other technique which I will tell you actually finite element also. So let's do first by finite difference one. So you already know the expression of the second derivative. So of in terms of the central difference formulation. So this is what you want to write for del square t upon del f square. Because here your would be two variables, one for x, one for y. So let's say x is changing from, x is being considered as I and y is being considered for j. So in that particular case, if you will write a temperature del square Tij with respect to x actually, so x, your the difference point is, you have considered the difference between two consecutive points at h. So you can write this is your expression. At this point till here.
Yes, sir.
Yes, sir.
So
Yes, sir.
only only variation is here is only x. You see j is same everywhere. So here also j ti minus 1j or ij I plus 1j. Okay. So you are a particular y and you are changing in x direction only. Therefore, you are just changing your I only. Fine. Same way in the bottom one. Now you are fixing your I, you are now changing your J. Let's say you are a particular X, now you want to move in Y direction there. So therefore you have here Tij minus 1 minus 2 Tij plus Tij plus 1, right? And this is the variation in distance in terms of Y direction, right? K. Okay.
Yes, sir.
Yes, sir.
So now you got everything in terms of I and j. You have formulations. Now you can change. You can take the number of the difference point in I direction, number of different points in y directions, and then you can generate your matrix. Correct or not?
Yes, sir.
Yes, sir.
Now, so that's what you have here. So you want to change I from 1 to n, j also from 1 to n. Now the choice is yours whether you want to generate it the symmetric matrix or asymmetric. So it's better to have a square size of the matrix. It always easy to solve actually in that way. So let's say first want to just generate, let's say 3 by 3. We are just taking three difference points, okay? So your I would change from 1 to 3. Your J would also change from 1 to 3. So this is what your problem is. The first one is just a metal block where its boundaries are maintained. This boundary at the 60 degrees Celsius. The right boundary is 100 degrees Celsius. Top boundary is 70 degrees Celsius and bottom boundary is 35 degrees Celsius. So you know all boundary temperature. At this boundary, this side, you always temperature is 60 degree. On right side, always temperature is 100 degree. Bottom side, where you have 00, 10, 20, 30, you know these temperatures are 35. Same way top one, 04, 14, 24, 34, 14. All temperatures are 70 degree. Okay. So wherever zeros are associated, you know those temperature from your boundary conditions. So this all zeros are known. This one all zeros are known. Top all actually fours are known because now you have their boundary, and this side is also the last one. Okay. So this is what would help you. And now these are your grid points. These are known the grid points here. So you have first grid point, second, third, fourth, fifth, sixth, seven, eight, nine. So these are nine grid points, and you are supposed to find their temperature values. So you have nine temperatures. Fine.
Yes, sir.
Hello?
Yes, sir.
Correct. Now we want to calculate it from our finite difference formulations. So this is how it look like a typical finite difference mesh. So this people say is mesh or grid formation, whatever you say actually. Now let's say go back our governing equations. So let's say at I equal to 1. Now you are fixing first here. If you say here, so I equal to 1 means you are fixing either a position of x. Now you want to change for j. So for I equal to 1, your j is getting changed from 1 to 3, right? Correct or not?
Yes, sir.
So at every time, your other variable would change from 1 to 3. Correct? That's what is your point to be considered. So let's say I equal to 1, j equal to 1. So practically you are calculating this point here. So if you substitute that here, I equal to 1, j equal to 1, your main equations, you will get this 4. You have two, this is your main equation which need to be solved, right? This is what, correct? Here you are putting I equal to 1, j equal to 1. Here also you are putting I equal to 1, j equal to 1. correct? Because
Yes, sir.
these two would finally would be plugged in this equation number 35. So main equation would be Ti minus 1 j minus 2 Ti j upon h square plus Ti plus 1 j. This would come here. Then this would also go here. Total would be one equation only. So I forgot to write here actually. So that would be your total equation. This would be your total equation. Sorry. Now this is I comma j would become twice actually. Therefore, is getting from two terms that I and k, and this is your last term there. So if you will put at I equal to 1, j equal to 1, your equation can be rearranged into this particular format. Fine.
Yes, sir.
Yes,
Now,
sir.
Yes, sir.
whatever is known that need to be taken to the right side because those are known will be treated as boundary. Whatever is unknown, keep it to the left side. So if you want to arrange it, you will get this actually that minus 2 upon h square plus 2 upon k square t11 plus t12. These are the only thing you know in this particular part. You also know T1, T21, so that I wrote here. So you got T11, T12, T13. Okay? You got from for I equal to 1, you have changed J 1, 2, 3. Fine? So you wrote all of them, whether they are present or not. If not present, just put a coefficient 0. Is that fine?
Yes, sir.
Yes, sir.
Now you change for t equal to 2 because you know t2 1, you don't know t2 2, you don't know t2 3 in first equation, this one 7.1. So those coefficient also need to be put 0, correct? So you have a one equation here 0 t2 2, 0 t2 3, correct or not?
Yes, sir.
At the same time, you don't have 3 comma 1, 3 comma 2 and 3 comma 3 because finally you have here all 9 variables, right? Correct?
Yes, sir.
These are the 9 variables. So every equation should have all these 9. So whatever is not present in this equation, just substitute them with 0 coefficient. Fine? So that I have not put here for time being, but that need to be put. So this is your known thing. Everything is known. T01 and T10. Everything is known from boundary. Fine.
Yes, sir.
Yes, sir.
Now you kept your I equal to 1. You have just changed J only. So if you will just change J again, you will get this another equation, and all known parameters has been kept to the this side. So this is wrong here. Actually, T13 is not known. This will move to this side because T13 is unknown actually. Okay. So this will move to this side. Now after
Yes,
that, you just change J equal to 3. So J equal to 3, this would be your equation now. So whatever is not present, just putting 0. Okay. So
yes,
this
sir.
you wrote everything for I equal to 1, then I equal to, okay, I equal to 1, you wrote j equal to 1, j equal to 2, j equal to 3. Correct or not?
Yes, sir.
Now you change I equal to 2. For I equal to 2, again you write j equal to 1, j equal to 2, and j equal to 3. So for that, if you will write that, so I equal to 2, j equal to 1, if you will write that, you will get this equation. Rearrange it in terms of known and unknown. All unknown to be on left hand side, known thing should be to right hand side. This term should not be there because this is unknown actually. This should move to this side. So I wrote it two places, here also here, so this should not be there. Okay. Fine.
Yes, sir.
Yes, sir.
Now for j equal to 2, you wrote the same equation again. So everything here is unknown. So you wrote this equation. Then j equal to 3, you wrote this equation. After that, you wrote for I equal to 3 now. I equal to 3, j equal to 1. So you wrote this equation. I equal to 3, j equal to 2, you wrote this equation, and I equal to 3, j equal to 3, you wrote. So you have changed your I from 1 to 3 also, j also from 1 to 3. Now we have to rearrange all these into a matrix format because that will make me easy how to solve it. Correct? So practically you got how many equations? You see here, this is one equation, I think. One, then you have two, then you have three, four, five, six, seven, eight, and nine. Correct?
Yes, sir.
You got nine equations and you have your nine variables. So what are your nine variables? T11, T21, T31, then T12, T22, T32. Then you have T13, T23, and T33. So you can write all of them maybe one by one. If you are interested this way, you can write T11, T12, T13 that way. Choice is yours, but all nine element, just fix up a pattern what way you want to arrange them. The rest of the things would be taken automatically. So let's say, let's write them in terms of matrix. So this matrix, first I generated for I equal just 2 by 2 mass, because this would help me how my matrix shape is getting changed. Because until unless I will not generate several configurations, I will not be able to write what will happen if I am changing from 3 through 3, or let's say 4 by 4 or 3 by 4, something like that. Because generalized program need to work for each and every configuration, right? So first I generated for 2 by 2. I changed for 1 to 2. J I also changed to 1 by 2, 1 to 2. So this was my matrix. Okay. And these my unknown temperature T11, T12, T21, and T22. Whatever was unknown there, their coefficient is 0 here. Is this fine?
Yes, sir.
So I generated first for only 2 by 2 mesh. So I got this matrix. You should also just generate and cross check it. This is just for a homework. After that, I generated for 3 by 3, for which we wrote the equation just now. So for 3 by 3, I am arranging this in terms of this. This is a coefficient of T11. This is T12. This is T13. This is T21. This is T22. T23, T31, T32, and T33. जो नहीं था, whatever coefficient was not present, those are 0 only. And these are my unknown temperature: T11, T12, T13, T21, then again T22, T23, T31, T32, and T33. Fine. So this is what I have arranged these equations. Fine. Okay.
Yes, sir.
So this is my matrix. Now this is my boundary condition matrix. This is how it's getting changed from previous 2 to now. Here you see from here to the next one, your matrix has changed drastically. It's not changing in the same pattern. So I have to be careful, right? So now you got a main diagonal which is same. This is just changing that way, minus 2 by h square minus 2 by k square. This is my main diagonal. So यहाँ से I am getting a train कि wherever I and j are same, my elements should remain same. Correct or not?
Yes, sir.
Now, if I see second element, so this is 1 by k square. This is also 1 by k square. So from 1 to 2 is same. After that, I am getting a 0. Again, for 2 rows, it is same. Again, I am getting a 0. Again, for 2 rows, it's same. So this is also a one sort of trend, that 1 by wherever you see here, the total is coming 1 plus 2 is 3, 3 plus 2 is coming 5, 4 plus 5 is coming 9. So you have 3, 5, 9. Here you are getting 11. Here you are getting 15. Here you are getting 17. Yes or no? I plus j ka total.
Yes, sir.
So that's way I found some logic that 3, 5 is this way. उसके बाद there is one skip. 5 के बाद 7 is not there. After that you have 9, 11, then 13 is not there. So these are the some which are getting 0 somehow. I don't know how to generate it, but this is some trend actually, right? Now you see from second row onwards, here you have again 2 comma 1, right? This is 2 comma 1. Correct? Hello?
Yes, sir.
This
Yes,
is
sir.
2 comma 1, this is 3 comma 2, and this is 2 comma 3. Both are same. 3 comma 2 or 2 comma 3, my element is same. Right or not?
Yes, sir.
Same thing here,
Yes, sir.
that 5 comma 4 and 4 comma 5, my element is again same. So you say this off diagonal is following same trend on left side and right side both.
Sir,
Correct or
I
not?
have a doubt.
Yeah.
So how do we write like for skipping? So like how do we write it in the MATLAB? So like
This is what your work, this is what I work. I did also, you should also think it. Okay? Everything can be done actually. Okay? First, we are thinking that what the train, what is the logic, what need to be generated or not. Correct? Then we
yes,
will
sir.
think. Now you see your fourth diagonal. Fourth diagonal is same, no doubt in that. You see everywhere 1 by h square, 1 by h square, 1 by h. So no change here. So you have here fourth diagonal is this is 5, this is 7, this is 9, this is 11, this is 13, this is your 15. So wherever you have this total here, you are getting 1 by h square without any doubt, right? But it's starting from 5. It's starting from 5. You see, 1 plus 2 is 5. So it's from 5 onward, 5, 7, 9, 11, 13, 15. Same thing here. You see here, fourth diagonal from fourth row onwards. This is again 4 comma 1, right? 5 comma 2, 6 comma 3. This is again same. So this one, fourth diagonal on left and right is also same. Third diagonal is also, so you see here, third diagonal is 0. This is here. Everything is 0, right? Correct or not?
Yes, sir.
Yes, sir.
So you have a main diagonal, second diagonal with the skipping of every two element. After every two, you are getting a 0. And fourth diagonal is actually 1 by h square. Third diagonal is 0 in both the sides. Fine. So this is how my matrix look like. Let's say 3 by 3, my trend is same. Now I want to generate it for 4 by 4. Let's see what will happen if I go for 4 by 4. And for 3 by 3, this is my matrix from boundary conditions. This is how it is being generated. So let's see what will happen for 4 by 4. So, oh, I am not shown here to 4 by 4 because I hope 4 by 4 train was same. Okay. So this would be the same train for 4 by 4 also, but I generated actually. Let me show you, because 4 by 4 I also generated. So, spherical heat transfer. Yeah, this one. Because until unless you will not do for one or two extensions, you will never ever to come that what is your generalized train. So this is, we have just stopped now. This is for 3 by 3. Now this is how is I got for actually, what is this? This is again same actually, 3 by 3 one. Yeah, it is 4 by 4 actually now. You can see this very long matrix actually. So it is in two parts actually. So this 4 by 4 again, you see that you have here zeros. After that, there are no element, right? Correct or not? You see everything is zeros. And after that also everything is the 0 here. And you see again that after a long time, you are getting again these elements. ये फिर से आ गया minus 2y h² at 9 by 9, 9,9 पे है, right? At 9,9, you are getting same. So 9,9, 10,10, 11,11, and this one actually. So is it same or it is ninth row? It is practically ninth row, okay? So आपके मैट्रिक्स में कोई चेंज नहीं है. This is from ninth row onwards. This is from your, how many rows are there? Here if you say 1, 2, 3, 4, 5, 6, 7, 8. 8 rows has come here. You will say there are no change here. Correct? Hello?
Yes, sir.
Now ninth row is same again. So ninth row is same. So यहाँ from here I can say कि my train is now not getting changed, and my matrix is finally the 16 by 16, and for me the elements are these actually. So from 3 by 3 to 4 by 4 mass size, my elements and matrix is not getting changed. Now I can think that how to write a generalized program. So your first part is just to generate these matrix. Don't take from me कि sir ने बना के दे दिया and now you are happy. It is just for your thing that okay, you should get something like that. Fine. Now you people have to think, जो आप मुझसे क्वेश्चन कर रहे हो, that how can we generate such type of matrix something. First you generate, can you generate this type of matrix or not? First you think,
Yes, sir.
let's generate this type of matrix, and for let's say for trial you are just getting यहाँ भी let's say somehow you are getting 1 by k square, because for you that would be easy, right? कि ये zero का concept for time being if you can neglect. So let's say here is also you are getting 1 by k square, here is also getting 1 by k square. Then I hope you can generate this matrix very easily. I hope so. Not very easily actually, it's not easy nahi. So you should think that how to generate this. First you can generate this 1 by k square. First you generate it somehow. After that, then you think, what can I do? How can I force this to zero actually? Can I think some general way that how can it force it to zero? At the same time, and once you will generate it, and for 3 and 4, because trend is same, it will automatically will be converted to 2 also without any problem. Okay, so this part I am leaving to you actually completely, because I want you to think before I can give the solution from my side, because if I will give, your brain will not work. Okay, it is your part to generate and formulate till here, because it will take the sufficient time whatever I covered today. And there is no rush. We want to finish it one day, everything. There is no such plan actually. So first you generate it, okay?
Okay.
Yes, sir.
Yes,
Okay,
sir.
so we have covered sufficient things today. So you generate it, think it, or